Here in this video, we are solving two questions from NEET in semiconductor devices basing on a concept of transistor actually. Let us see what is the problem is. First problem, in a common emitter transistor amplifier, audio signal across the collector is 3 volts. That means what is given for you is voltage across the collector is 3 volts. The resistance across the collector is 3 kilo ohms. Once you know these, I can simply apply Ohm's law. V equal to IR, 3 equal to I across the collector and 3 kilo ohms. So I across the collector is 3 by 3 kilo ohms. That is 1 by 1000, that is 10 power minus 3. That is 1 milliampere. That's the current across the collector. If the current gain is 100, what do you mean by a current gain? Being it is a common emitter transistor for input as well as the output. Emitter is common, other end of the input is base, other end of the output is collector. Then the current gain beta equal to output current IC by base current eliminating the common element. That was as collector current is much more than the base current, amplification factor is large and that is given for you as 100. I already got IC and I know beta, so I can get IB as what? Beta equal to delta IC by delta IB. Beta is 100, delta IC is 1 milliampere by IB. So IB is, or delta IB is 10 power minus 3 by 100, that is 10 power minus 5, that is 10 microamperes. I got both what we have to say, collector current and base current. Now you want voltage amplification factor. Voltage amplification factor is simply as voltage equal to IR, current amplification factor and resistance amplification factor. What is current amplification factor? IC by IB. Resistance amplification factor is RL by RI. IC by IB is nothing but beta. So beta into RL by RI. Beta is given as 100. RL is the collector resistance, that is 3 kilo ohms. RI is the base resistance, that is 2 kilo ohms. So this becomes 50 and 3, 150. So voltage amplification factor is 150, so automatically this is the answer. Of course, we can also calculate power gain or a power amplification factor as power equal to something like V into I. So that is voltage gain into current gain, right? Power is voltage gain into current gain. Voltage gain, already I have written a formula, beta into RL by RI. Current gain is again beta because it's a common emitter configuration, that is beta square into RL by RI, that is 100 into 100 10 power 4. RL is 3K, RK is 2K. So if you calculate that, you will get that value as 15,000. So this is the answer for the problem. That's how we get that first problem. Let's have a look at the next problem. It's a similar problem somehow. I'll just move it to this side. Yeah, see this. In the second problem, what is given for you is, in the second problem, it can be given that an NPN transistor connected to a common emitter configuration to a given amplifier, load resistance is 800, connected to a collector circuit of 0.8 volts. Let's write down the data. RL is 800 and voltage across the collector is 0.8 volts. So from these, basing on what we have learned earlier like this, I can use the formula V equal to IR, 0.8 equal to I across the collector, resistance is 100. So I across the collector is 0.8 by 800, that is 8 into 10 power minus 1 by 8 into 10 power plus 2, that is again 1 milliampere, same to that of the previous data. Okay. If the current amplification factor is 0.96, see what here there is a kind of a data error that what he has given for us, right? So when he says it's connected in a common emitter configuration, it was given that it's a common emitter configuration. In common emitter configuration, output is IC, input is IB, because emitter is common. That's called amplification factor beta, that's always greater than 1. But he has given an amplification factor 0.96, that is possible only in a common base configuration. In a common base configuration, base is common. So output is at the collector, input is at the emitter, but emitter is more than that of the collector, so this will be less than 1, which is called as alpha. So he has given alpha for you, not a beta, so that it was a little mess up in the question. I don't know whether questions marks were added to this or not as of now. I don't remember, but it was a wrong data. Once if it is alpha is given for you, he has actually calculated the power gain and voltage gain for that alpha itself. So to show that that I will first find out the values of that voltage gain in common base configuration. Voltage gain equal to, it's actually alpha into RL by RI. See here, voltage gain equal to, here we have written a formula, beta into RL by RI in common emitter configuration. In common base configuration, the amplification factor is alpha. It was given as 0.96. Output voltage is given for you as 800 ohms. Input is given for you as 192. So this is 20 times 20 by 800 is 4. So voltage gain is 4, that is available in all these options, so any of this is correct. So what he has calculated is for, because if we calculate a voltage gain here, for example, just to tell you, here voltage gain in this configuration could be written like as what? Beta into RL by RI. Beta we have to find out using a formula. Once alpha is known, beta equal to alpha by 1 minus alpha, that is 0.96 by 1 minus 0.96, that is 0.96 by 0.04, that equal to 96 by 4, that equal to 24. So voltage gain is 24 into 800 by 192. So 24 is of 8 times, 24 8s are 192, so 800 by 8 is 100. So voltage gain is 100, but none of the options are carrying that 100. So it is obvious that what he want, like common emitter configuration voltage gain, is not true. He want actually to find out not common emitter, but he want it for common base. You shall change the question itself actually. So if you start working for common base, you can further solve the question as what? Similarly, power gain equal to voltage gain into power current gain, that is alpha square into RL by RI, that is 0.96 into 0.96 into 800 by 192. So if you calculate that value, you will get that as 3.89. So that's how you will get an answer, but be careful that what he has not given is not in question is not correct. It's not for common emitter, but he has calculated it for common base. For common emitter, you won't have any options available. Therefore, though it's a wrong question, it becomes easy for you to identify that it's a wrong question. Thank you for watching.